Hello everyone, we are going to do our last set of notes for the year. So we're doing series and parallel circuits and other kind of cool things we can do circuits. So let's set up our page for Cornell notes. So we do a line along the side and two across here. Put our name up top. And the date, what it'll be, 4/19/21. So we're still talking about series or circuits for this one. I know circuits were our last one as well, but I feel like it works for this one as well. Circuits. The essential question. How do I tell the difference? For series and parallel. So we're going to talk about series and parallel circuits, and I want you to be able to tell the difference at the end of this. So our first one is series. And in a series circuit, the devices are connected in a line. So, for example, a flashlight. So we're going to just draw a real quick picture. So this X stands for a lamp. And then we have a little dash and a big dash. The little dash is the negative side of a battery. The big dash is the positive side. So they would be going this direction, so negative to positive. That's not what's important. What's important is that it's in series. These two bulbs are in line with each other, so they're in series. Yeah, okay. The next one is a parallel. So these ones, the devices are connected, so there is more than one path. To follow. So example for this one is a house. Alright, so let's draw this picture. Oops. Put a lamp there. That's really far apart. Ugh. Those are supposed to be closer, whatever. So in this case, we have a path, oh shoot, so path this way or path this way. So the electrons could go to this bulb or this bulb. If I cut it right here, this bulb will go out, but this one still works. Whereas if I cut it really anywhere on this one, the whole thing just stops working. Alright, so those are series and parallel. The next thing we're actually going to talk about is an electromagnet. we did not talk about magnets a whole lot this year. We still need to do that. Maybe we'll take a day and just spend it on magnets. So this is electromagnet, and it's a magnet formed by an electric current. Alright, and we can do this by having, that's a battery, right? And I'm going to say that that's a nail, and we take a wire, and wrap around the nail, and connect. And that turns it into, so it's negative, so positive, and that causes this curls, these turning, whatever, causes it to have a magnetic field. And so we'll have the magnetic field lines, which we don't know anything about yet because we didn't talk about it, but they would go out the top and bottom. And you can pick up paper clips and stuff, or car parts. Alright, so an electromagnet's pretty cool. And it kind of leads us into these other two things. And that would be an electric motor and an electric generator. Did I spell that right? I did. Nice. Okay. So an electric motor turns electrical energy into mechanical energy. And a generator, an electric generator, does the opposite. It turns mechanical energy into electrical energy. And these are actually swappable. So if I have an electric motor, I could put electricity into it and it'll spin. But I can also spin it and create electricity, which is pretty neat. Now obviously some generators are specifically made for that, and so they produce more electricity, and motors, they're specifically made to do the one thing they're made for, so electrical energy, and they'll spin really well. So they may be not ideal for doing the opposite, but it's still something that could potentially work, which is kind of cool. And I think that's where we're going to stop. I had a few other things that deal with magnets, but like I said, we haven't really talked about it, so it wouldn't make sense. So thank you, and we will see you guys later.